Welcome to all. Today some special type of questions. See, first I will cover question 68. From a circle, a big circle, a small circle is cut out. I will do some 2-3 questions first. See, first one. Find moment of inertia about center of the axis. You can make a small note here. See, if you want words from a circle of radius 100 millimeter, another circle or a circular cutout is made which is the edge of which is at 15 mm to right of center and bottom edge is left edge is 15 mm to what? Right of center and the bottom edge is 18 mm above the center. See this section. First write usual. What usual? I cannot tell now. Usual. Moment of inertia required about centroid of the axis I x x I y y. Therefore, first you have to locate centroid G. See here, this is a case of what we will do is you write the sketch once again. See, write the sketch once again, then write. We will take 1 is the full circle, and this we will take 2. So the real or actual is 1 minus 2. So accordingly, x bar equal to a1 x1 minus a2 x2 divided by a is a1 minus a2. Same formula for y bar. You know all these things. Start. Draw a neat sketch. I try to draw as neat as possible. See. 100, 100, diameter 200. 100, 100, diameter 200. For this circle, cutout circle, radius 20, so diameter 40. And see, project here. See, from here to here is 15. From here to here is diameter 40. If you want, from here to the right extreme edge is, from total 100, subtract these two, you get 45. Same way, mark here 18, 40, 40 plus 18 is 52. From 100 subtract, 42 will come. 58, subtract 42. Start. X bar. A1, full area, pi by 4 of 200 square into, see, its centroid is here, into x1 is exactly 100 or 200 by 2 minus a2, pi by 4 of 40 square into x2, its centroid from here, 100 plus 15 plus another half of 40. Divided by a1 minus a2, you get x bar this way. I won't waste time every time writing. X bar comes this way, y bar. Before that you write, consider reference axis OX, OY here. That is Abelco. Same way, y bar. Full area A1 into y1. y1 is 100. This area minus this area into y2 is 100 plus 18 plus half of 40. Divided by a1 minus a2 will give y bar. It comes to 98.417. Now, important, immediately locate centroidal axis. Okay. I'll remove this one now. This full I'll remove, 68. Next 69, I'll make a note here. Okay, this I'll remove now. I can write up to here, I think, most probably. Up to here, no problem. Okay. Locate centroidal axis. Okay, see, x bar, how much you got? 98.542. That is little before centroid is 100, or common sense. If the circle is not cut out, centroid will be here. Since you are removing something, centroid will shift away from that one, this side. So, how much? 98.452. 98.452 means it will be, see, somewhere here. Not to scale, y axis from here to here is 98.452. Then this distance will be from total 200, subtract it, you will get 101.458. Okay, same way, y bar 98.417. From here to here is 100, little below. This is your x-axis. From here to x-axis, this is 98.417. Then from the top extreme edge, see, the top extreme edge to this axis, from here if you calculate, it will be from total 200, subtract it, 101.583. So locate this one. Okay, now start moment of inertia. Usual calculation of moment of inertia about x and y. We know moment of inertia about any axis equal to moment of inertia Ig plus a square. What is Ig, what is a square is explained in the class. I do not know how many times I explained. So write all those statements, including the statement parallax theorem. That is your problem. If you don't write a usual statement. So first I'll go for Ixx. Start. You can do one thing, okay. Ixx for 1. Ixx for 1. 1 means full circle. Equal to, start. Come to centroid. Axis passing to centroid, parallel to x-axis here, see, this axis. For a circle, I is pi by 64 into diameter power 4, 200 power 4 Ig plus area, pi by 4 of 200 square is the area into square of the distance, what? From centroid G1 to x-axis, this distance square is 101.583. Subtract from here up to here is 100 or 200 by 2 whole square. Get the value of Ixx for 1. Then Ixx for 2. Moment of inertia about x-axis of this cutout portion. First about its own centroidal axis. Once again same formula. How much? Pi by 64 of 40 power 4. Diameter is 40. Plus pi by 4 of 40 square is the area into, see correctly now, into from centroid G2 to x-axis, see, this distance square is 101.583 from this full distance. Subtract 42, also subtract half of 40, that whole square, calculate. Now do the usual, you complete. Therefore, final Ixx equal to Ixx for 1 minus, not plus actually, because actually is 1 minus 2. This also I told, Ixx for 1 minus Ix for 2, or this answer minus this answer will give Ixx. Okay, start. I about Yy. First, right here. I about Yy for 1. First, come here. Its centroid is here. I about axis pass into centroid, parallel to Yy is this axis. See, this axis. Pi by 64. Because for a circle, any axis pass into center, pi by 64 into 200 power 4 Ig plus area, pi by 4 of 200 square is the area into from centroid G1, see, from centroid G1 to Yy, this distance square is 101.458 minus from here to here is 100 or 200 by 2. That one square. Get the answer. Then Iyy for 2 is, come here. First, I about its own centroidal axis here. See, pi by 64 of 40 power 4 equal to pi by 64 of 40 power 4 plus area pi by 4 of 40 square is the area into from centroid to YY perpendicular square, that is 101.458 minus, okay, from here to here we want. So 101.458 minus 45, see from here to here is 45. From the right extreme edge up to edge is minus 45 minus half of 40. Minus 45 minus half of 40 whole square, calculate, then complete the question. Therefore, IYY is for entire area, given area, or for a circular area with a small circle cutout is IYY for 1 minus IYY for 2. This is question number 68. Here, what I have done, I removed the circle, that is called eccentrically. See, in a structural member, if the cross section is circular, sometime for some reason, maybe for some pipe, usually for beams pipe they don't put actually, okay, some reason they make a circular hole randomly anywhere. But now I will take up another case. What I will do is, the cutout is not random here, it is either here or here. Means it is symmetrical about one of the axis. One I will do in the class, other I will give you exercise for you. So that is next question 69. Then short question is, it is cut out exactly center. Then it becomes hollow circular section. 1 minute. Now, two questions, 69 and 70, both are identical. 69 I will solve. This is class question. 70 is exercise for you. Exercise. You should do it. Okay. Start this question. See, same way. Circle of radius 150. That is a full circle. I will take 1. See, I will take the full circle as 1. For this one, diameter equal to 300. Then, see, I will take this full circle as 1 and this cutout I will take 2. This cutout is 2. For cutout 2, diameter is radius 45, diameter is 90. Now, where cutout? See, the center of the cutout lies in this central axis. See, these two are at the same level, but this way no shifting, no vertical shift. Last time, see, it was somewhere here, horizontally shifted, vertically shifted. Now only horizontally shifted. Next question, only vertically shifted. Okay, this gap is 25. So 25 gap here. This is 90. 90 plus 25 is 115. From 150 subtract 35 will come. Now, before you start the question, you write the sketch once again and make a note there. You should write. See, if last time there was no axis of symmetry, so x, x, y, y both you located, but this time see here, this is perfectly, you write the sketch once again. You write the sketch once again and then write, this is axis of symmetry, that is x-x axis. So, see here, you can directly mark the x-x axis. No need of locating x-x axis by calculation. If you want distance, already there, 150, 150. Okay. Now, I forgot one thing. I did not mark G1, G2. See, this is your G1, this is your G2. Okay. Therefore, see, it is symmetrical about this axis, but not symmetrical here. So, therefore, you have to write YY axis, you have to locate. So, therefore, YY to be located using x bar. Now, origin not required. You find x bar from reference vertical line AB, this side. Start. X bar equal to A1 x1 minus A2 x2 divided by area A1 minus A2. A1. pi by 4 of 300 square into x1 150 minus a2 pi by 4 of 90 square into x2. It's centroid from here. See? 100, 150 plus another 150 plus 25 plus half of 90 divided by a1 minus a2, x bar will come 143.077. So mark now 143.077 means, see, it will be somewhere here. Less than 150. Okay. This is 147.077. Then from the other side to this axis, total 300 subtract, it will come 156 point, how 156? 143, 143. Actually correct, it is 156.923 because I got a shock. It is 143, not 147. I was wondering how it is possible. Okay. 143. Then only total 300 will come. Okay, now this is centroid G. See, now be careful. See, this is your G1. Okay, write this one. Now, I will tell now only. For next question, when you start the next, after this question I complete now, then you start next question. You should do it. I will not tell anything. What you do is, right here, this is the axis of symmetry. See here. This is axis of symmetry. That is your YY axis. Therefore, YY directly locate. But the XX axis, you have to locate using calculation. So what you do is, you find instead of X bar from the reference line here, you find what? Y this way, find Y bar. Your 100%, your Y bar for next question from bottom edge will come same 140, your Y bar will come, my guarantee, because why I not change the question. Your Y bar this way will come 143.077 or from the top. So therefore it will be, see, somewhere here 143.077. From the top edge it will come 156.923. Next question, these two are symmetrical, 150, 150. These two distances are 143 here and 156 there. If you cannot do that much, I am helpless. So you should solve independently and get the answer. Okay, now I will continue the question now. And also one more thing. This question, whatever IXX you get, you will get it for IYY there. This time, whatever you get IYY, that answer you will get when you calculate IXX there, interchange. That's a check for you. Okay, start now. Calculation of I about XX. Usual story you write. IXX for 1, little later, IXX for 2, then usual formality. Then calculation of IYY. IYY for 1, okay, green color, 1, then IYY for 2. Before that, remember, you have to write all the usual, what, calculation of moment of inertia by parallaxis theorem, that all you have to write. Okay, start. I about XX. Come to centroid. Axis passing to centroid parallel to XX. Oh, same axis. See, your G1, G2, both are lying in XX. So when you do IXX, when you write IG plus A square, 0 square will come. But not for YY. When you do I about YY, see, distance square will come. Now, next question what will happen is, when you do IYY, both 0 square will come. When you find IXX, distance will come. Okay, start. IXX. Pi by 64 of how much diameter? 300. Okay. 300 power 4 plus area pi by 4 of 300 square area into, I already told you, your centroid G1 lies in XX into 0 square, get the answer. Then for 2, pi by 64 of 90 power 4 Ig plus pi by 4 of 90 square area into once again 0 square. Calculate. Then Ixx equal to Ixx power 1 minus Ixx power 2. Start Iyy. See, come to centroid. First about its own centroidal axis. Pi by 64 of 300 power 4 plus area pi by 4 of 300 square into from centroid G1 to Yy, see this distance square. This distance square is 156.923. 923 is this full distance. Subtract 150 minus 150 whole square. Calculate the answer. Iyy for 2. I about its own axis. Pi by 64 of 90 power 4. See, I am little fast I am doing because now time has come to increase the speed. So many questions are solved. Therefore, the small things is not a problem now. Pi by 4 of 90 square is the area into from centroid G2 to Yy this distance square, that is 156.923 minus 35 again minus half of 90 minus 90 by 2 whole square. Calculate, then complete the formality. Therefore, final Iyy equal to Iyy for 1 minus Iyy for 2. When you do next question, what expression you wrote for Ixx, that will come for Iyy. What expression you wrote for Iyy now, that will come for Ixx. This question we found x bar. Y bar is not required because xx symmetrical. Next question, yy symmetrical. So x bar not required, y bar you require. What x bar you got, same y bar you will get there. So answer also you can check it. So therefore this question solved 70. Now 71, actually I will do in single stretch only because there is nothing there. Next question is more important. 71. It is not a question first of all. I am not pausing the recording because it is so simple. I will finish now only. This I will remove. See, 71. Next question. Question 71. Actually, it is not a question. Find same Ixx, Iyy. I won't waste. Find Ixx and Iyy. All dimensions are in millimeter. See. Circle, another circle, cut out. This is the area. Here, now. This radius is 250 and then this distance some randomly given 250 half is 125, say 120. This is the question, center. See, that is from a circle of radius 250, another circle is cut out in the exactly center. The outside edge of that circle is at 120 from outer edge of the circle. Now, write the question. Now, immediately write a note. Oh, you can write, this is symmetrical. You write the sketch once again. This is symmetrical about both xx and yy. See? These both are axis of symmetry. This will be your xx, this will be your yy. Therefore, there is no need of finding x bar or y bar. Directly go first consider first the outer circle. There is nothing there. Outer circle, okay. Somehow I tried circle. This is of diameter. How much? 500. Why 500? 500. Then it does not look like a circle. Okay. Someone will be laughing. See the circle he is drawing. What to do? There's a limit for everything. Okay. Somewhat neatly. Okay. Further. You don't worry about these things all. Okay. How much I can try. Okay. Now see. Now you do one thing. Make a note here. This full circle is 1 and cutout is 2. So full circle is 1. Cutout is 2. Now see here. We want diameters. This much work is not required actually. I will tell you that later. This I told you earlier because this you get repeatedly in strength of materials. And see here. Okay, see here. It is given in the question. This radius is how much? 250. If that is 250, this also 250 out of scale. So this full is 500. Or when this radius is 250, for 1, its dia is 500. 500. Okay, same way. This one, we want diameter. For this one, its diameter. See here. In the question they told, see here. If I mark center here, they have given this distance and see whether given here or whether given here, both are same. See everywhere 120. This is 120. If that is 120, this is 120. This full is radius of 5. Radius is 250 for outer circle. 250. So this will be 130. This also 130. So this dia is 130 minus 130, total 260 is the diameter. Or directly you can do here. See, this radius is 250. So dia is 500. From 500, subtract 120, you get diameter of the inner circle, that is 260. Okay. Now, directly mark, see, this is your, now, this is centroid of G1, and also comma, it is centroid G2. So this center of the circle is centroid for both. Therefore, this is the x-axis, this is the y-y axis. Later will be direct formula. Y-y, mark here. Y-y, x-x. Start. Find moment of inertia. I about x-x. Available space I will write. Or 1 minute. Remove this one now. Okay. Start. I-x-x. I-x-x for 1 and I-x-x for 2. I-x-x for 1 and I-x-x for 2. I-x-x for 1. Actually, this much struggling is not required. See here. I about its own centroidal axis. Pi by 64 of 500 power 4, Ig, plus area. Pi by 4 of 500 square into centroid lies in xx, 0 square. Calculate the answer. I-x-x for 2. Again, first about its own centroidal axis. Pi by 64 of how much diameter? 260 power 4 plus pi by 4 of 260 square into once again 0 square. Therefore, I-x-x finally equal to I-x-x for 1 minus I-x-x for 2. You write the answer. Then note IYY is equal to IXX. See? Why? No, there is no change. If you turn by 90 degrees, there is no change here. But not for previous question. Your IYY, same way it will come. See, again, G1, G2 lies in YY. IYY equal to IXX. Now, make a note. Make a note. In strength of materials and also in cylinders, cylinder you won't get, and also in torsion. Of course, in torsion you get, and in strength of materials, so many questions, and also in columns, or so many questions in strength of materials, you will get a term called hollow circular section. Hollow circular section. Circular section, or some people call hollow cylindrical section or pipe section. Pipe section. I told you long back, in such cases, then you need not write sketch, etc. See, one cross section you write here. See, this way and this way, whatever is there. A little. Okay. In such cases, you show the sketch. See, I'll tell you what to do. Write the sketch here. One circle, out of scale. First you mark outer diameter. I will call always outer diameter as D1 in my class. In the question they told, this is 250, so this is 500. Then project inside and mark the inner diameter. I will call D2. D2 is 500 minus this thickness 120 minus 120 will give you 260. Okay, then directly long back I told you, you forgot it, then directly area if you want is pi by 4 of D1 square minus pi by 4 of D2 square, or you can take pi by 4 common into D1 square minus D2 square, or equal to pi by 4 of 500 square minus 260 square. In a simple stress and strains, you require area. And also remember, your I about XX equal to I about YY equal to pi by 64 of D1 power 4 minus pi by 64 of D2 power 4, or you can tell pi by 64 of D1 power 4 minus D2 power 4. Don't make the foolish mistake of writing pi by 64 of D1 minus D2 whole power 4. No, or equal to pi by 64 of 500 power 4 minus 260 power 4. That way find moment of inertia. Over. Now, last question, 72. This is the closing part for today's class and the circular part. I will tell you what I will do. Question. See, this question I solved earlier. There is a semicircle. Semicircle. And another semicircle is cut out. Oh, here problem is there. This way. See, this is one semicircle. This is another semicircle. This question I solved long back for locating centroid, but I will explain once again. This is the last question, 72 for today. I will write the question neatly and then solve. Start. Question 72. See, find IXX, IYY. Question is, see, this is center. There is one circle here. From a big circle is there. So actually not circle, sorry, semicircle. From the semicircle, inner side, another semicircle is cut out. So, see, this is the existing area. Now, this is a question. Make a note if you want. First one thing, make a note. It is very powerful note. See, first of all, later, see, note. For this semicircle, first of all, inner one, the inner semicircle, radius 125, So diameter is 250. See, 125 radius, diameter is 250. For the full outer, this full semicircle, this is 125, this is 50. So 125 plus 50. 125 plus 50 is 175 is the radius. So diameter is 350. That much common sense required. Now, our actual is, we will do one thing now. See, you put the sketch, then write. See, full semicircle, we will take 1. This cutout, we will take 2. So actual is 1 minus 2. 1 minus 2. And also remember, see, when you take the full semicircle, see here, its centroid G1 is at 2d by 3 pi, 2 into 350 by 3 pi, 74.272. Whereas for this empty portion, again semicircle, its centroid G2 is 2 into 250 by 3 pi, 53 point something. So later see, this G1 is centroid for the full semicircle, full. G2 is only for the cutout portion. Now, this is 175 total. See, they told 125 here, 50 here, 125 here, 50 here, 175, 175, 350. This much should be clear for you. Now, start. Now do one thing, write the sketch once again and write there. See, this is perfectly symmetrical about y-y axis. Y-y axis. This is axis of symmetry. Therefore, no need of finding x bar. We have to locate only x-x axis. Look, we have to locate x-x axis using y bar. So y bar we will take from the base. See, start. Refer base. I will take AB axis, some name. From AB, y bar equal to centroid for the entire, this one is A1y1 minus A2y2 divided by total area A1 minus A2. A1 is semicircle of diameter 350 full. Removed one is semicircle of diameter 250. So okay, start. A1 pi by 4 of 350 square into centroid of that one is 2d by 3 pi of 2 into 350 by 3 pi minus area of this inner semicircle pi by 4 of 250 square into 2d by 3 pi 2 into 250 by 3 pi. See, that centroid is upper side, this is lower side. You will get divided by A1 minus A2. You will get, oh sorry, it is not pi by 4. Actually, we are doing so far circle. Okay, no problem. Forgot. Actually, so far we are doing circle. So it is semicircle, pi by 8. Okay. Sometime it happens. See, when I was writing, I forgot it is semicircle. Because previously we had done only circles. So habit, okay, no problem. It has no effect because that pi by 4 or pi by 8 gets cancelled. Anyway, that much I have, a concept I am knowing. So pi by 8 and pi by 8, you get the answer. 96.377. Now see, 96.377 means where? From here to G2 is 53. Furthermore, from here to G1 is 74. So it is slightly above. 1, go that side. You are disturbing me. 1, you go there. Why disturbing me? Okay. Therefore, your centroid will be from the base at 96.377 means see, up from here up to here is 2 into 350 by 3 pi is 74. So it is little above. And from here up to here is 125. So 96. See. This is your x-x axis. From here to here will be 96.3377. Then from the topmost edge to this one will be total 175. 175 minus 96 point something is 78.623. 623. This is 377. Okay, now make a small note. After 72, I will give one more question for you, 73. You will work out. Identical question I will give you. What I will do is, I will give like this, see. This way I will give. Same dimensions. There, see, this is symmetry axis. Xx need not be located. Yy you have to locate, find x bar. That x bar from here will come same as y bar from here. Make a note. That is question number. Next exercise question for you, 73. After this question is over, one exercise question. See, I am giving question number. If it is only exercise, I need not give question number. Means I will consider that as a full question for you. You have to solve it. 72 over, 71 is correct. 72 is, I think, correct, I think, most probably. Now I am getting confusion. 69, 70, 71. Okay, 72 is correct, most probably. Otherwise, I will adjust next class. Just a minute, I will just check it. But I do not want question number to be mistaken. Okay. When everything is over, next question is full exercise for you. Same as this question. See, no change. Find Ix, Iyy this way. I told you here, Xx is symmetry. Yy you have to locate. What y bar you got here, you will get that x bar here. Solve this question for a complete grip. Okay, now start. Find moment of inertia. First, see, calculate. Write the usual. If you are finding moment of inertia about xx and yy, parallax theorem, that all you write. And remember, final answer is 1 minus 2. Okay, start here. First, this sketch I still maintain. See, come to 1. For 1, see, its centroid is here. See, its centroid here. I about its own centroidal axis. For a semicircle, this is not symmetrical. So, 0.00686 into diameter power 4 plus area into from centroid G1 to xx. See, this distance square is 96.377 minus distance of G1 from here is 2 into 2d by 3 pi, 2 into 350 by 3 pi whole square. How much I explained earlier, so this is sufficient. Okay, same way, come for 2, about its own centroidal axis. 0.00686, 250 power 4 plus area into G2 to xx. See, this distance square is 96.377 minus this distance is 2d by 3 pi, diameter is 250 by 3 pi whole square. Calculate both, then Ixx final equal to Ixx power 1 minus Ixx power 2. Okay, then calculation of Iyy. Next, calculation of Iyy. See, what calculation you got here for Ixx, that calculation will come for Iyy here. Okay, Iyy. I'll change it here now. 1 and 2. Start. Iyy. So first come to G1. This is G2. I about its own centroidal axis for this full semicircle. Oh, this is symmetrical. So not decimal now. Now it is pi by, this also told for you thousands of times. Nobody should ask. Pi by 128 into 350 power 4 plus area into from centroid G1 to G1 lies in YY. So into what? 0 square. Same way, Iyy for 2. I about its own axis for this semicircle is pi by 128 into 250 power 4 plus area into once again, okay, red is not required, red color only, okay, into once again 0 square. Final Iyy equal to Iyy for 1 minus Iyy for 2. Complete this question. Understand the concept. Now, solve this question. What y bar you got here, that will come x bar. Xx symmetrical. What calculation you did for Ixx here will come for Iyy there. What calculation you did for Iyy there, here just now, that will come for Ixx. So complete the question 73. Next class is 74. I write it out here. Sometime I forgot. Next 74. Now, see these questions for centroid also I considered. Now, I'll once again go back to old pattern now. This I thought, as I went through the centroid problem, suddenly I saw this type of question solved there. So I thought, today, because you are in touch with semicircle, see last class, earlier class all, you are fully in touch with the circle, semicircle, quadrant. So I thought, better in a stretch only complete it. Okay, now, next class, I'll continue. Question number 74. Thank you.